By the end of today's lesson, you will be able to graph an absolute value function by using a given domain to create a table of values. Here, in example 1, we have function g of x, which is equal to the negative of the absolute value of x plus 2 over the interval of negative 5, which is less than or equal to x, which is less than or equal to 1. Now this inequality here gives us our domain. This negative 5 tells us where to start. And because it has an or equal to sign, we know we would use a shaded circle by negative 5. The positive 1 tells us where to stop the domain, and would also have a shaded circle because it has an or equal to. So if we wanted to create a table of values, we now know where to start the domain and stop the domain. To title our chart, x is our input, and g of x is the title for our output. So now we know where to begin. We want to input negative 5 and every integer between negative 5 up until and including 1. So negative 4, negative 3, negative 2, negative 1, 0, and 1. Okay, now to find the output values, we can use our calculator. So if we go to y equals and we want to type in this function, g of x, we need to first hit negative and then hit the math button, go over to the number menu, and go down to, it's actually choice 1, hit enter. And then we can enter x plus 2 and close the parentheses. Your calculator is updated and should show up with the bars rather than seeing this word abs, but it will work out to be the same. So now let's hit second graph and we will see the table. This table begins at 0. We want our table to begin at negative 5. So we have to hit the up arrow key to find more negative numbers until we see when the input is negative 5, the output is negative 3. When the input is negative 4, the output is negative 2. When the input is negative 3, the output is negative 1. When the input is negative 2, the output is 0. And then we notice that this pattern continues afterwards. So if 0 is here, negative 1, negative 2, and negative 3. This tells us when there's a pattern that the vertex must be the point or the turning point in the center. So our vertex for this absolute value graph is actually negative 2, 0. So now it's time to plot our points. At negative 1, 2, 3, 4, 5, down 3, 1, 2, 3, I can plot a shaded circle. Sometimes from my interval, right at the beginning, I'll leave myself a note that this should be a shaded circle, and so should 1. Every value in the middle is defined, so negative 4, negative 2 would be a regular point, negative 3, negative 1, and then we have our vertex, negative 2, 0. Our vertex is our turning point, so now I can go negative 1, negative 1, 0, negative 2, and then another shaded circle for 1, negative 3. When I connect the points, I try to make my line as straight as possible. Luckily I have this tool here to help me out. You can use a ruler or a straight edge, or just do your best. And I am always sure not to include arrows if I am given a domain. I should also name the function, so next to this function I will title it g of x. Okay, let's take a look at example 2. For example 2, we have the function y equals 3 times the absolute value of x minus 4 minus 5. This time, I have to start my domain at an x value of 0 with a shaded circle because it is included, and I have to stop my domain at 6, but I have to use an open circle because it's actually not included in the solution set. All real numbers between 0 and 6 are included, but I cannot include 6. So let's title our chart so we could set up our table. I have to use x for the input, and this time they did not name the function, so I can use y for the output. I'm going to begin my table at 0, and I'm going to leave myself a note that this is a shaded circle. And I'm going to increase my integers until I get to 6. 1, 2, 3, 4, 5, and 6. But by 6, I'm going to put a reminder that it should be an open circle. Okay, let's use our calculator again to get the output values. So if I go to y equals and clear it out, I this time have to hit 3. You do not have to hit the multiplication symbol. You can just hit your math key, go over to the number menu and choose choice 1. Again, yours should show up with a box, and you can enter the x minus 4 inside the box, but then I have to close the parentheses. If you have the box, you have to hit this right arrow key until you get out of the box and then hit subtract by 5. So yours on your calculator could look like this. 3, and then it had this little box here, and inside here you put x minus 4, and then you close it and get out of it by hitting the right arrow key, and then minus 5. Okay. So now let's find our output values. If I hit second graph, it'll take me to my table. This time I do not want my table to begin at -5. Instead I want to begin at 0. So I need to scroll down. I see 0 has an output of 7, but I want to place 0 at the beginning of my screen. So 0 gives an output of 7. 1 gives an output of 4. 2 gives an output of 1. 3 gives an output of -2. 4 gives an output of -5. And then it appears to have a pattern. -2 and 1 again. This time, my vertex seems to be here, because after the -5, I see the repetition of the pattern going upward and downward surrounding it. So my vertex is not in the center of my table, but that's because I did not choose my domain. This domain was given to me. I have no choice. So let's graph. Alright, first point is 0, climb up 7, and it's a shaded circle. There's a 1, up 4, 2, up 1, 0, and then 3, -2, and then 4, -5 is my vertex. So 4, -5. Let's see. Here. And then I repeat the pattern, but I cannot go all the way. I go to 6, 1, and I put an open circle. Again, we want our lines to be as straight as possible. I'm going to use this little tool here. And you can use a ruler or a straight edge. And now we need to name our function. This time they did not name it by g of x or f of x, so I have to write out y equals 3 times the absolute value of x minus 4 minus 5. Okay, for examples 3 and 4, this would be a good point in time for you to pause the video, try it on your own, and then press play to check your answers. Alright, good luck. Okay, let's see how you did. First thing you should check is if your points in the table, or your ordered pairs rather, match my table. You should also make sure you have an open circle here on the graph and a closed circle here. Make sure that you did not put arrows and that you named your function h of x. Notice the vertex is here because the pattern starts to repeat surrounding the -3, 0. For example 4, make sure that you titled your graph, your xy chart, with x and y. Make sure you have a shaded circle on either end. and make sure you labeled your picture. The vertex happens to be in the center for this one because the pattern surrounds the negative 3 comma 0, which I'm not sure if you already noticed, but this vertex is actually the same vertex as the one in example 3. My question to you is, why do you think they are the same? Take a look at their graphs, take a look at their equations. Come in tomorrow prepared to answer the question, what makes the vertex the same for example 3 and example 4? Take another look at their equations and come up with your idea. Have a great day.